Okay, so in this lesson, we're going to learn how to multiply radicals, and then we're going to simplify those radicals. Now, in previous lesson, we simplified radicals. So, in particular, for example, remember when we had something like simplify the square root of 45. We're going to look at this example first. So remember, this is a review. So let's call this part a review. And so when we simplified this radical, and this is a square root, we looked for a perfect square that would go into 45. And so we always chose the largest perfect square. So in this case, the largest perfect square is 9. So we wrote this as the square root of 9 times 5. And then in that lesson, we wrote this square root of a product as the product of the square roots. So it would be the square root of 9 times the square root of 5. And then we just simplify the square root of 9 because 9 is a perfect square. And we saw that the square root of 9 is 3. So we get 3 square root of 5. Now, what I want you to understand here before we go into our new lesson is that you see how I'm multiplying two square roots? Now remember, the index is 2 here. The index is 2 here. Since the indices are the same, I can multiply the radicands. Remember, these are called radicands. The radicand is 9. The radicand is 5. So 9 times 5 is right here, 9 times 5, which is 45. So in this lesson, you're going to use this idea here, that the square root of 9 times the square root of 5, I can write as the square root of 45. Okay? So that's what we're going to use in this new lesson. All right. Now, the other thing you need to remember is this. If I want to simplify the square root of, let's say it was 24 x cubed y to the 4th power z to the 8th. Let's say we had that. So simplify the square root of 24, x to the 3rd power, y to the 4th, z to the 8th. Now remember, we're simplifying this. So write this out in steps. So the first thing we're going to do is rewrite these as the product of each individual square root. Okay? So I'm going to get the square root of 24 times the square root of x to the 3rd power times the square root of y to the 4th times the square root of z to the 8th. All right, so write it out. Don't do too much in your head because you may mess up at some point. So just write it out. That way you can see it. Okay, so then we simplified each radical, each square root. So in this case, we're looking for a perfect square that goes into 24, and let's choose the largest. So the largest perfect square that goes into 24 is 4. So I can rewrite this as the square root of 4 times 6. Over here, so remember the index is 2. Okay, so my exponent here is 3. So what we did in the previous lesson was we rewrote x cubed. So we asked ourselves, what is the largest whole number less than 3 that 2 goes into? And the answer is 2. So we rewrote this as the square root of x squared times x. So remember, when you multiply like bases, you add exponents. 2 plus 1 is 3. So you learned that part last semester about the properties of exponents. So when you multiply like bases, you add exponents. Over here, this is already an even number. So I'm going to leave this one alone. So I'm just going to rewrite this as the square root of y to the 4th. And this is already even as well, so I'm going to rewrite this as the square root of z to the 8th. Okay, and now let's apply each one. I'm going to circle the parts that I can simplify. I can simplify the square root of 4. I can simplify the square root of x squared. I can simplify the square root of y to the 4th. And I can simplify the square root of z to the 8th. So I'm going to get the square root of 4 is 2, square root of 6. The square root of x squared is x, square root of x. The square root of y to the 4th is y squared. And the square root of z to the 8th is z to the 4th. All right, so now what we're going to do, what we did, so here's this idea here where we had the square root of 6 times the square root of x. So the square root of 6 times the square root of x is the square root of 6x. So that becomes 2x y squared z to the 4th times the square root of 6x. Right. So this is basically a review from the previous lesson. Okay? All right, now let's talk about the new lesson. Number 1. Now this is going to be, the direction is going to probably say multiply and simplify. All right, so multiply and simplify. Okay, number 1, we have the square root of 6 times the square root of 12. Okay, square root of 6 times the square root of 12. All right, so based on what we saw here, where you notice that the square root of 45 is the square root of 9 times the square root of 5, and basically what I'm doing is I'm multiplying the two radicands. 9 times 5 is 45. So there is a property that we can use, and it's called the product rule for radicals. Product rule for radicals. And so basically, now you got to assume that if you have the square root of a and the square root of b, and those are real numbers, then I can say this. Then I can say that the square root of a times the square root of b will equal the square root of ab. Okay? And so if you think about the previous lesson, that kind of is what we used here. The square root of 6 times the square root of x is the square root of 6x. Okay? So what you want to do here when multiplying and simplifying is actually to multiply the radicands first, since the index is the same, and that's all we're going to deal with in this lesson is square roots. So the indices will already be the same. And in this course, the indices will be the same. So you won't have the square root of 6 times the 4th root of 12. You won't see that. It will just be square roots. And so we're interested here in this course. So the square root of 6 and the square root of 12, and you're just going to say 6 times 12, so it'll be the square root of whatever 6 times 12 is. So if you don't remember what 6 times 12 is, use your calculator. You're going to say 6 times 12 equals, and you get 72. Okay? Now that takes us back. See the square root of 72? That takes us back to the previous lesson where we simplified the square root of 45. You had a worksheet on that. So the previous lesson, you're looking for a perfect square that goes into 72, and always use the largest. So the largest perfect square that goes into 72 is 36. So I can write this as the square root of 36 times 2. And so I'm going to rewrite the square root of the product as the product of each individual square root. So it'll be the square root of 36 times the square root of 2. And I'm going to circle the part I can simplify. So I can simplify the square root of 36 because 36 is a perfect square. And so I get 6 square root of 2. And so that's your answer. And remember, always put the radical on the outside, on the end. Put the radical on the end. So the square root of 2 will go here. All right, now you can, if you want to, say the square root of 2 times 6, like that. But it doesn't, that's not the way we mathematically write it. Because sometimes some students will put the 6 so close to this that it looks like a square root of 26, and it's not. All right, so this is how we write it. So write it like this. Okay, so always put the radical on the end. All right, number 2, suppose we had this. Suppose we had the square root of 7 times the square root of 7. All right, well, same idea. So you're multiplying 2 square roots, so we're going to write it as 1 square root. So to write it as 1 square root, we're going to multiply the radicands together. 7 times 7 is 49. So I get the square root of 49. But I want you to notice that 49 is a perfect square. And so the square root of 49 is just 7. Now, notice that the radicand was a perfect square. And notice how I got that perfect square. See how these radicands here were the same? So this is 7, this is 7. I ended up with the answer being 7. It's not a coincidence. It's the fact that when the radicands are the same, and we're saying these are real numbers here. So when I'm multiplying two numbers and they're the same number, I'm going to end up having a perfect square. So for example, the square root of 8 times the square root of 8. 8 times 8 is, now notice 8 is not a perfect square, but when I multiply 8 by itself, it is a perfect square. That's the square root of 64, and the square root of 64 is 8. Okay? And so what I want you to get from this, well, let's look at this one. So let's write this is number 3, and this is number 4. So number 4, suppose I had this, the square root of 10 squared. Well, first of all, notice that the square root of 10 squared means the square root of 10 times itself. And then 10 times 10 is 100. I'm using the product rule here for radicals. So the square root of 10 times square root of 10 is the square root of 100, which is a perfect square. And that's our discussion from this little part here. The radicands are the same, so when I multiply those two numbers, since they're the same, it's going to end up being a perfect square. 6 times 6 is a perfect square, which is 36. 9 times 9 is 81. 81 is a perfect square. 11 times 11 is 121. 121 is a perfect square, and so on. And so the square root of 100 is just 10, which is the radicand we had. All right, so what I want you to notice from these three examples here, numbers 2, 3, and 4, is this. If A is a positive number, then the square root of A times the square root of A is just A. It's just a radicand. The same thing is true with this little part here. Also, the square root of A squared is just A, because the square root of A squared means the square root of A times the square root of A, which is what we saw here, and that's just A. Okay? All right. Now, let's look at number 5. Okay, number 5. So number 5, you have this. You have the square root of 15x times the square root of 15x. The square root of 15x times the square root of 15x. Well, notice that the radicands are the same. So what do you think this answer is? All right, think about what you think the answer is. And if you said the answer is 15x, you're correct, because the radicands are the same. So when I multiply these out, it's going to end up being a perfect square, and the square root of that's going to be that radicand. All right, so if you said that was equal to 15x, that's correct. Now let's do the long way if you need to. So remember, 15 times 15, if you don't know what that is, then we use your calculator. 15 times 15 is 225. So I get the square root of 225. X times x is x squared. All right, now let's use information from the previous lesson. So I'm going to write this as two square roots. So it'll be the square root of 225 times the square root of x squared. But 225 is a perfect square. 225 is just 15. 15 times 15 is 225. If you didn't, now for some, 225 is a large number, so some of you may not have recognized that 225 is a perfect square. Then just use your calculator. Just see if it is a perfect square. So you can take the square root. So you're going to press the second function, and then see where the x squared is. See this square root function right here. So you're going to press that. So you get the square root. Then do 225, and then press equal, and you get 15. So since 15 is a whole number, the square root of that 225, which is 15, is a So 225 is a perfect square. Over here, the square root of x squared is just x. The square root of x squared is just x. You'd say 2 into 2 is 1. That's all you do. Alright, so notice that you could have done it a long way, which is what we got, but just notice that whenever the radicands are the same, it's just that radicand. So basically you're saying this. So let's use our our understanding here. The square root of 47 x to the fourth y times the square root of 47 x to the fourth y is just what? Don't multiply it out. You know that these radicands are the same. 47x to the fourth y, 47x to the fourth y. So when you multiply it out doing the long way, you notice it's just going to be the radicand. So the answer is going to be 47x to the fourth y. All right, now again, that's assuming you can use this idea only if the radicands are the same. If you're taking the square root, also this has to be square root. So only if the radicands are the same. Okay? All right, now let's look at number 7. Okay, number 7, you have the square root of 12xy squared, 12xy squared, that's being multiplied by the square root of 3xy. Okay, 3xy. All right, so I'm going to use the product rule for radicals. So since the indexes are the same, indices are the same, I'm going to multiply the radicands. 12 times 3 is 36. X times x is x squared. When you multiply like bases, you add exponents. Y squared times y is y cubed. Okay, so that's just your next step. Now you're going to simplify this. So basically I'm going to write this as separate radicals. So I'm going to get the square root of 36 times the square root of x squared times the square root of y cubed. Okay? Now, you're going to rewrite these looking for perfect squares. Well, 36 is already a perfect square, so leave that alone. X squared, the exponent's already even, but here that's an odd exponent. So let's go ahead and rewrite this. I'm going to say that's 36, square root of 36, square root of x squared, times the square root of, and then remember in the previous lesson we asked ourselves, what's the largest, I'm going to rewrite y cubed, so what's the largest exponent that 2 goes into? That's less than 3. So that you'd say y squared times y. All right, because y times y is y cubed. All right, so now you're going to rewrite this part just like we did here. So you're going to say square root of 36, square root of x squared, square root of y squared, square root of y. And now remember, this part's a previous lesson right here. The new part's this. So going from here to here is we're using a product rule for radicals. All right, and then this is a previous lesson. This right here is a previous lesson. This is a new lesson right here. Okay, square root of 36. I'm circling the parts I can simplify. I can simplify all of these right here. That's all I can simplify. All right, so the square root of 36 is 6. Square root of x squared is x. Square root of y squared is y. And then I'm left with the square root of y. And so that's your answer. Okay, number 8. Number 8. Let's suppose we had 2 square root of 3x to the 7th times x square root of 6x. Okay? So 2 square root of 3x to the 7th times x square root of 6x. Okay, first of all, let's multiply the factor that's in front of the square root. So this factor is a 2, this factor is an x. So 2 times x, I get 2x. Now let's multiply the radicands together. So let's multiply these two radicals. So I'm going to get 3 times 6 is 18. X to the 7th times x. Remember, you multiply like bases, you add exponents. X to the 7th times x is x to the 8th. All right, so that's what I have. Okay, now let's rewrite this as much as we can to help us to simplify this. Don't leave it as language because it can be simplified. So hence the idea where it said here, simplify. Okay, well, 18 I can simplify. So because 9 is the largest perfect square that goes into 18. So I'm going to rewrite this as 2x times the square root of 18 times the square root of x to the 8th. And then remember, 18 is 9 times 2. So I'm going to write this as 2x times the square root of 9 times 2. Since 8's already even, I'm going to leave it alone. Square root of x to the 8th. All right, now I'm going to rewrite this as a product of two radicals. So it becomes 2x square root of 9 square root of 2 square root of x to the 8th. I'm going to circle the parts I can simplify. I'm going to circle the parts of the radicals I can simplify. Okay, radicals. So I can simplify the square root of 9, and I can simplify the square root of 8. So I'm going to get 2x, this is a 3, so I'm going to say times 3. This I'm going to leave alone, that's square root of 2, and this is x to the 4th. Square root of x to the 8th is x to the 4th. Now remember, just like we said earlier, always rewrite the answer so the radical's on the end. Okay? So the only radical I see is this. I'm going to put it on the end. So I'm going to rewrite everything else. Now be careful. X times x to the 4th is x to the 5th. X times x to the 4th is x to the 5th. And then 2 times 3 is 6. So I get 2 times 3 is 6. X times x to the 4th is x to the 5th. And I'm left with the square root of 2. And so that's your answer. That's what you would write it as. Okay, number 9. Number 9. Suppose we had this. Number 9. Okay, suppose we had the square root of 8 x y cubed times the square root of 3 x squared y cubed. All right, so the square root of 8 x y cubed times the square root of 3x squared y cubed. So let's write this as one radical. So since the index are the same, so these are both index of 2, hence square roots, I'm going to multiply the radicands together. So I'm going to get the square root of 8 times 3 is 24. X times x squared is x cubed. Y cubed times y cubed is y to the 6. Now that's the new part. That's our new lesson. Our new lesson is going from here to here. So that's called the product rule. We use the product rule for radicals. All right, now we're going to use the previous lesson where we simplified these. Okay, so to do that, just like we did before, we're going to rewrite the square root of these products as the individual products. So I'm going to say that's going to be the square root of 24 times the square root of x cubed times the square root of y to the 6. And then we're going to simplify these radicals as much as we can. So for the square root of 24, what you got to think about, what perfect square, the largest perfect square that goes to a 24 besides 1? Well, in this case, it's 4. That's the largest. And so I'm going to rewrite this as the square root of 4 times 6. Now you got to ask yourself, can I simplify the square root of x cubed? Yes, you can. Since 3, the exponent, is bigger than the index, you can simplify. Bigger than or equal to, I should say. Since 3 is bigger than or equal to the index 2, I can simplify. But it's odd, though. It's an odd exponent, so you got to rewrite it. So remember, you got to ask yourself, what's the largest whole number less than 3 that 2 goes into? And the answer is 2. So I'm going to rewrite this as x squared times y. I'm sorry, x squared times x, excuse me. X squared times x, because remember, you multiply like bases, you add exponents. 2 plus 1 is 3. Over here, I can simplify this. I can simplify the square root of x to the 6 because my exponent is bigger than or equal to 2. But this is an easy one here because my exponent's already even. So I don't have to write it like I did x cubed. I'm going to just leave it as the square root of y to the 6. Okay, now I'm going to rewrite the product of the square root of this product as individual as a product of each square root. So it'll be square root of 4, square root of 6, square root of x squared, square root of x. And then this, I'm going to leave it as square root of y to the 6. Okay, and then now we're going to circle, just like we did in the past. We're going to circle the parts of the radicals. The parts of the radicals I can simplify. Right, so here, since 4 is a perfect square, I can rewrite the square root of 4. I can simplify that. Since the exponent's even, I can simplify the square root of x squared. Now here I cannot simplify the square root of x because that exponent 1 is less than 2. All right, so that's as simplified as this can get. I cannot simplify the square root of 6 because the only perfect square that goes into 6 is 1. And so that's as simplest as square root of 6 can get. Over here, I can simplify this because since it's even and is bigger than 2, the index 2, I can simplify that. All right, now let's simplify each one. All right, the square root of 4 is 2. The square root of x squared is just x. And the square root of y to the 6 is y cubed. 2 goes into 6 3 times. And all this product goes in front of the radical. Now you see this right here? You're going to use the fact that the square root of 6 times the square root of x, using the product rule for radicals, is the square root of 6x. So that's going to, so in our answer, you're going to say that's going to equal 2xy cubed. Remember, that's a product because all these are products. Square root of 4 times the square root of 6 times the square root of x squared times the square root of x times the square root of y to the 6. So I get 2xy cubed times the square root of 6x. And so that's your answer. Okay, number 10. Number 10, you have 3x square root of 5x times 2x squared square root of 5x to the 9th. So 3x square root of 5x times 2x squared square root of 5x to the 9th. Okay, so what I'm going to do first of all is look at these factors that's not under a square root. So this 3x and this 2x squared, and I'm going to multiply them together. So 3 times 2 is 6. X times x squared is x cubed. And I'm going to rewrite the radicals, the product of these two radicals as one radical. So that's going to be the square root of 5 times 5 is 25. X times x to the 9th is x to the 10th. So when you multiply like bases, you add exponents. 1 plus 9 is 10. All right, now let's see what we get. I'm going to rewrite the square root of the product as individual products. So that'll be 6x cubed times the square root of 25 times the square root of x to the 10th. And then let's simplify each of these square roots. But notice, though, that 25 is already a perfect square, so there's nothing else I can do. I can simplify this real easily now. And then here, the exponent is 10, which is even, so that's a good thing. So right away, I can simplify these two square roots. So I'm going to get 6x cubed. So that becomes times 5, and that becomes times x to the 5th. 2 goes into 10 5 times. And now, notice the answer. So in our answer, though, there's not going to be a radical. There's not going to be a square root because you don't see any here. And so I get 6 times 5 is 30. X cubed times x to the 5th. So remember, you multiply like bases. See the base x, they're the same. So when you multiply like bases, you add exponents. 3 plus 5 is 8. So I have 8 factors of x here. So 30 x to the 8th. So there's your answer. Okay, number 11. Number 11, you have this. You have the square root of 10xy times the square root of x squared y cubed times the square root of 5y to the 4th. All right, so in this case, I'm multiplying 3 radicals. But the indexes are the same. They're all square roots. And so that means that I can use the product rule for radicals. So I can just multiply the radicands together. So let's see, that's the coefficient here is 10. That's under the radical. In this radicand, the coefficient is 1. In this radicand, the coefficient is 5. So 10 times 1 times 5 is 50. Let's get the square root of 50. X times x squared. There's no factor of x here. So x times x squared is just x cubed. So when you multiply like bases, you add exponents. 1 plus 2 is 3. Now let's get the factors of y. Y to the first times y cubed times y to the fourth. So you have y to the first times y cubed times y to the fourth. So when you multiply like bases, you add those exponents. 1 plus 3 plus 4 is 8. So I get y to the 8. All right, now we're going to rewrite this as the product of each individual factor. So it'll be the square root of 50 times the square root of x cubed times the square root of y to the 8th. The square root of 50, 50 is not a perfect square, so I want to simplify each one, but 50 is not a perfect square, but there is a perfect square other than one that goes into 50, and that's 25. So I can rewrite this as a square root of 25 times 2. Okay, now here I can simplify this because my exponent is bigger than 2. Here, and x is 2. But it's odd, so you want to rewrite it. So you're gonna rewrite it as the square root of. So remember, the largest whole number less than 3 that 2 goes into will be 2. So you can rewrite this as x squared times x. Here, 8's already even, so I'm just going to rewrite this as square root of y to the 8th. All right, I'm going to write this as all these square roots here, where I have the square root of a product, and we write them as the product of these square roots. So it'll be the square root of 25 times the square root of 2 times the square root of x squared times the square root of x times the square root of y to the 8th. All right, now let's circle the ones I can simplify. So I can simplify this square root. I can't simplify the square root of 2 because the only perfect square that goes into 2 is 1. I can simplify the square root of x squared. I can't simplify the square root of x because the exponent is 1 and 1 is less than 2. And I can simplify the square root of y to the 8th. All right, so the square root of the square root of 25 is 5. The square root of x squared is just x. And the square root of y to the 8th is y to the 4th. And so I'm going to rewrite those. See how I have the square root of 2 times the square root of x? You want to use the product rule for radicals. Product rule for radicals. And so you're going to say that the square root of 2 times the square root of x is the square root of 2x. And so this becomes, remember all these are products, so this becomes 5 times x times y to the 4th. So our answer is going to be 5x y to the 4th times the square root of 2x. And so that's your answer there. Okay, so that's going to take care of the part 1. And remember, part 1 is where we just multiplied radicals and we simplify them. That's part 1. Okay? All right.